1 second. Let me do one other thing. Okay. Here we go. Welcome, everybody. I'm Joe D'Antoni. Today I'm going to be talking about building a big data architecture. A little bit about myself. I'm currently a big data and solutions architect at Anexinet company. Anexinet. We're a consulting firm on the East Coast of the U.S. We cover mainly Philadelphia and the surrounding region. I've done a lot of work with Hadoop and other big data platforms. I kind of started getting into this in my last organization. We had several applications that just weren't necessarily great fits for relational databases. And we'll talk a little bit about that today as to how you can determine, when an application is not a good fit for something like SQL Server, and when you may want to do a good bit of your processing over in a Hadoop type environment. So I speak frequently on database administration, big data, and career management. I'm also president of the Philadelphia SQL Server user group, and I organize SQL Saturday Philadelphia. And just a warm welcome to everyone who's attending. Good evening if you're in Europe, and good morning if you're in Asia. And I'm hoping you're having a good afternoon if you're on the West Coast or of the U.S. It's snowing here in Philadelphia. I also want to make sure you can restore your data. It's funny, we talk about this in Hadoop and a lot of things. Backups become less important because kind of in an Azure type sense for keeping multiple copies of our data, but it's still, we should be able to recreate it if we need it because our data is very important. Lastly, you can find me on Twitter, Facebook, and LinkedIn. I'm JDanton on Twitter if you have any questions. So today's agenda. We'll talk a little bit about the history of these big data platforms. The graphic I have on the screen here is the yellow elephant. The yellow elephant is synonymous with Hadoop. The guys at Yahoo who basically wrote Hadoop, named Hadoop after one of the gentleman's sons had a stuffed yellow elephant that he named Hadoop, and that's how it kind of got its name. Believe it or not, some of the foundations of Hadoop have been around for about 10 years. And we'll talk a little bit about, some of the white papers that were involved from Google and some of the research that's been done and how this is kind of becoming a more mature platform. Hadoop 2.0 was recently introduced, and having been involved in the space for several years, I can say early on it was very, very immature in terms of the platform. And now it's definitely a lot more mature to the point that Hadoop 2.0 has something that almost resembles a CPU scheduler that we traditionally associate in a relational database. It's called a resource manager. YARN is the acronym, yet another resource manager. So we'll kind of move from there, from the history to where we are. We'll talk about the main components of the big data architecture, and we're going to talk a lot about Hadoop today. And I know we hear a lot about other NoSQL solutions. Hadoop's kind of the center point. It's really just a distributed file system and a MapReduce framework, but that really drives a lot of our other applications that either sit on top of Hadoop or interact with it. But it's traditionally the center point of all of these big data architectures just due to its sheer flexibility. We'll talk a little bit deciding between the cloud and bare metal. There are a couple of really good cloud Hadoop kind of as a service offerings from both Microsoft and Amazon. Microsoft has HDInsight. Amazon has Elastic MapReduce. We'll kind of take a look at the cost and walk you through a process for how you might determine what the best solution is for your organization. There are several things to take in mind, much like any other cloud versus not cloud decision. You want to understand your company's needs and the long-term objectives of your project. So we'll talk about that. Then we'll talk about the right architecture for your company, and this is kind of determining what components of the stack you need, based on how much data you have, how big your plans are for growing a big data solution. And then lastly, we'll talk about some next steps and how you can get started with this. I'll give a couple of samples and There's a few downloads and books that I'd recommend that'll help you get started. One of the other things we're going to do is a brief demo of Hadoop, where we're going to show a file getting loaded, and we'll connect to it from Power Query using Excel. So let's get going. Some background, and I really am not a big fan of the term big data. It's kind of like cloud. Both of those terms I don't love, but they're not going to go away. We see this trend here, and this is a Google search trend, and we can see that interest in the term big data was beginning to arise in 2011, and it really started to take off around 2013, and it's continued to grow throughout this year. So that's very it's very interesting from our perspective. Excuse me. Sorry about that. It masked wrong. It's been interesting. It's been interesting from my perspective to see how this has changed. We still have a lot of clients that are very interested in it, but I find that larger clients are still wanting to go to more traditional solutions, and that's understandable because these kind of solutions, such as Hadoop and some of the other new SQL products, really take a different developer mindset and a different set of system administration mindsets that we can get. So training's different, and your programmers have to think differently, and it's just the whole thing's a big change from our previous the paradigms we've done in the past. So kind of looking at Hadoop by itself, this is kind of the history of it. A couple of guys were trying to build a better search engine, and they named it Nudge. This started in around 2002. It was pretty well. It was going pretty well. It was able to crawl and index hundreds of millions of pages, and they were thinking that the web search engine needed to be around 1 billion. So a couple of guys outside of Yahoo did that. But really, Yahoo was responsible for the vast majority of the development in the formative years of Hadoop. So what happened was Google released this file system white paper in 2003, and it was kind of definitive on building a distributed file system that provided high availability, gave some resilience for drive failure. And one of the things that drove that was reducing the overall exposure to storage costs. Storage has traditionally been one of the most expensive parts of enterprise IT, and particularly fast SAN storage of the kind that traditional relational databases need to use. Relational databases tend to do a lot of random I/O, so you need really fast disks to service that I/O. In all of these big data solutions are really designed around doing large swaths of sequential I/O to the point that we're not even doing RAID. So we're kind of in a RAID 0 scenario in the server, but within the cluster we have 3 copies of our data. So it's kind of an interesting paradigm that's completely different from what we do in the relational world. In 2004, Google came out with a MapReduce, or there was a MapReduce white paper, which was also pretty definitive. MapReduce is the framework that we use within Hadoop, and it lets us break down large volumes of data. So finally, in 2006, Yahoo really got started with Hadoop. So this is a lot of people when they say it's the birth of Hadoop, and it wasn't just Yahoo. It was a full-on Apache project that attracted users and contributors from around the world. Some people like Tom White, who's Welsh, who wrote the first O'Reilly book, Hadoop: The Definitive Guide. He just really liked the software and wanted to stay up all night and play with it. Google had some contributions to MapReduce, and so the project started to get more mature. The thing was, during this time frame, it was really hard to use Hadoop. I did some early experiments with it, and you had to have things like, you had to have the right Java library, you had to compile it yourself. There was no real easy installer. Even though in 2008, Yahoo had 100% of their critical services running on top of Hadoop, it still wasn't easy to use. However, in 2008, Cloudera began, and in 2011, Yahoo spun off Hortonworks as a separate company. And what the goal of these companies has been is to produce a usable Hadoop tool. And I'll kind of demo a little bit of Cloudera Manager in a few slides. And it really is a lot easier. One of the things you can download at the end, I'll have a link to, is a sample VM that's got all the components. But the Cloudera installer is just amazingly easy to use, to their credit. So big data versus traditional BI. We're generally associating big data with these Vs. There's some wide number of Vs depending on who you talk to. Volume, so we have lots of data. A good example I like to refer to is in my previous company, we had an event management system that every time a network event happened, we had to record it. And we had a lot of customers, so it was a really massive system. It was about a 55 terabyte database, and we were loading it into a relational database. It didn't make a whole lot of sense given the type of processing we did. So that would be one place where I'd see volume as being an exceeding thing. Variety, having many different formats makes it really hard to do integration. One of the most common uses for a Hadoop environment is to do ETL. As much as I love integration services, Hadoop makes certain types of ETL operations really easy to do, relatively speaking. Additionally, we apply a schema at read time typically, as opposed to having to have a clearly defined schema. So if we wanted to do different types of analysis on a set of data, it's something we could do. Velocity, the rate of change in data. So a lot of this comes into social media kind of spaces where we're doing making decisions based on rapidly changing data. And then lastly, variability. So this is kind of one of the other Vs. I've seen some other Vs like value, where that can also be applied. But the way we do these things are by parallelizing the processing. So we go to distributed systems, which we do give up a little bit of consistency, but we have perfect availability. Big data solutions tend to trade off consistency for the other two. That doesn't mean they're never consistent, but the consistency takes time to replicate through the system. This makes big data warehouse appliances, or data warehouse appliances rather, so something like parallel data warehouse, even though they're large scale and parallel, not necessarily big data solutions. And the common technical themes of our big data solutions are this. And this kind of applies to the NoSQL solution. Oh, I'm sorry, we lost the slide there. This kind of applies to the NoSQL solutions as well as Hadoop. And there must be some kind of built-in animation there. We have, they're designed for analytics processing, and man, it really does want me to show that slide. So typically we have built-in high availability, right? So there's no, my slides are on some sort of time thing here. Okay, I'll just talk for a second. Typically we have a highly available solution that we can scale horizontally. We're using cheap local storage as opposed to SAN storage, and we're going to have 3 copies of our data. That's really where we're providing our redundancy. So in the event that a server goes down or a hard drive goes down in one of those servers, we're never going to be down. By default, we're going to be highly available. So let's talk a little bit more about the Hadoop ecosystem. In each of these graphics or components within our ecosystem, HDFS and MapReduce are kind of the center of the ecosystem here. HDFS is our distributed file system that we'll talk a little bit about on the next slide, and MapReduce is our programming framework. It's a parallel Java framework that's got automatic retry built into it. It's pretty powerful, and it's relatively easy to use if you've ever done any coding in C# or Java. So that's kind of what makes up Hadoop. Apache HBase is a columnar database that's designed to put real-time analytics on top of a Hadoop file store. It's something that's a little bit more challenging to use. Here we have Flume, and And what Flume does is Flume takes streaming logs. So one of the common uses of Hadoop is fraud prevention or log management. So if we have a lot of logs, we may load them using Flume agents that stream them into our Hadoop cluster very rapidly. So that's a common use. Impala and Hive both kind of aim to do the same thing. They're data warehouse layers that sit on top of Hadoop and provide us a SQL-like engine into Hadoop. So we'll do a quick Hive demo in a bit. Pig here is another scripting language that resembles Python a great deal and allows us to interact with our data within Hadoop that way. Mahout's a machine learning technology, and what machine learning is basically if the data set analyzes a certain condition within the data, it will take another action. Typically, we see these used with expensive equipment. So perhaps like a restaurant chain's walk-in refrigerators, that if they see a certain condition that may be indicative of a coming failure, it will automatically either phone a technician or perform some other diagnostic to protect it. And then lastly, we have Scoop. Even though it's SQOOP, it's pronounced Scoop. It bothers me a little bit. And that's a way of extracting data out of Hadoop and into a relational database. There are a few ways we can do that, and we'll talk about that in a bit. So this is kind of our sample traditional cluster, and here we have our name node and our secondary name node. And our name node's the master for the cluster. It knows where all the data that resides in our data nodes are. In our data nodes, we're going to have 3 copies of our data across a great deal of disk. And later we'll talk about what these servers should look like, but this is just kind of what the logical architecture of a Hadoop cluster is going to look like. And here's how MapReduce works. This file that we're accessing is called access log, so we're accessing a very large 256 megabyte log file. The MapReduce jobs are going to split this data into chunks, and each server is going to probably get its own task to parse through 64 meg of the data. One thing you'll note is we're doing a lot of full table scan type operations. Everything's really a scan in Hadoop. We're not doing a whole lot of seek operations. That's kind of why the sequential I/O operations are the driver, and we can get away with using slower disk instead of random I/O. So let's take a look at this in practice. Okay, hopefully everyone can see my screen. I don't see questions popping up. So here, I'm actually on my name node, and I have a file that's local to my file system called census2010.dat. It's just a data file.
We don't see your screen yet. We see the Hadoop demo slide.
All right, let me refresh.
Okay, there we go. Now we see it.
Okay.
Great.
So here we're going to show, we're going to load this file into our Hadoop cluster. This file is local to my name node, but it's not currently in my cluster. So we simply do a -put command. You may have seen this before. And if I go over here to one of my cluster nodes, I can now see that file, even though it was loaded into the cluster. And if I want to view it, I can do a .cat or -cat. Whoops. As you can see, it's a bunch of numbers. So how do we interact with that data? Here I'm going to run a Hive script. Hive, or HiveQL. which is going to look a lot like SQL. You'll see this create external table, and we have it stored as a text file. And then what we're going to do is do a select from it. So let's go ahead and run this. So what's going to happen here is we're going to create a table, and we're going to not physically load it with data, but kind of put a pointer to it, and then we're going to query it. This query is actually building a MapReduce job. Even though I did this query here, select star from census where population is greater than 5,000, it's building a MapReduce job in order to do that. And that's exactly what Hive and the tools like Impala do, is build a MapReduce job so we don't have to write Java, which makes our lives a lot easier. That took about 20 seconds, which isn't exceptionally fast. Our speed comes at scale, so we're not necessarily looking for this to be the fastest right now, but it will scale and go to large volume. So in terms of interacting with this from the Microsoft BI stack, we also have Power Query, which is pretty new. It's still in beta. We have the option to connect directly to Hadoop. In here, I'm going to enter the name of my name node, or in this case, its IP address. And it's going to show me all of these files. One of the things I have loaded that we've been playing with is Enron emails, but here I want to look at the census file that I just loaded. And as you can see, I can add that. I can select it from Power Query and add it to my data model, even though it concatenated all the data. Ooh, that was pretty ugly. Power Query is still in beta. But that's kind of a little bit of a nutshell of how Hadoop works. So let's go back to the slides. Okay, if anybody has any questions now, let's see. Didn't think I see anything. Okay. Okay. Okay, I think everybody's good with seeing the screen. So why do we want to leave the relational database? One of the main reasons I've seen with many clients relates to money. Relational databases have gotten really expensive, especially in the data warehouse type environments where we really need the enterprise edition features. SQL Server changed to core based licensing. And this isn't going to eliminate the relational database by any means from our equation. We're always going to need them for various transactional systems. But if we can cut back on the number of cores we have to license for a very large warehouse operation, so if we're doing a lot of our warehouse pre-processing in a Hadoop type system, we can greatly reduce our license exposure. The other thing, these big data type systems are going to scale a lot better than a traditional data warehouse. We can only scale up so much on a data warehouse workload. We can only buy so many CPUs in a server and so much memory. And this isn't for every data warehouse. This is, when you start talking about petabytes of data, it gets really challenging to do that in a relational environment just because of the overhead. We're limiting a lot of our overhead. We're also limiting a lot of our options. But let's talk about some of the modern architectures we might see. This is a fairly common architecture that I've seen. Where all data is fed into a Hadoop store. Sorry about the slide changing, guys. Actually, hang on 1 second. Let me just kill animations.
Joseph, one of the questions we have is, were you using HDInsight for the demo?
Actually, that was Cloudera Hadoop running on Linux. We'll talk a little bit more about HDInsight in a bit. Something's going on with my animation. Sorry about that. Yeah, that was Cloudera Hadoop on Linux. So HDInsight has the same components, and the syntax is going to be exactly the same. So that slide I wanted to show you guys before. I apologize. But basically, if you can picture it, you have a data warehouse as one of the end goals. So your goal is to reduce the amount of volume on your data warehouse. So you're using Hadoop in order to break down a lot of that data. So you may be collecting more data than you would have had you been in a regular data warehouse scenario. So you're collecting all of the data, and then you're sending what you traditionally would to your enterprise data warehouse. But then you're sending some data to an analytics engine, where if you have a team of data scientists, which is an overused term, but if you have a team of data scientists or just people who are kind of hacking at data, can take a look at it and do some interesting analytics. So we're still going to have an enterprise data warehouse. We're going to have Hadoop and its ecosystem. We're going to have this analytics engine, which may be Excel, it may be SAS, it may be R. There are a number of analytics tools that are out there. And then lastly, we're going to have this visualization engine. And there are a number of products that can do this as well. We can go to Tableau, we can go to Power View, and Power Map. Just yesterday I was playing with Power Map and some IRS tax return data. So the Microsoft BI stack definitely works with all these solutions. But we're going to have that visualization engine just to show that stuff off. But our main focus for this architecture is going to be Hadoop and its ecosystem and how we build around that in your company. So Hadoop architecture. Some of the decisions we have to make, and I like this picture. I found it today. It's an example of bad architecture. There were some other ones that were far worse, but I thought this was kind of fitting. We're going to have to select a distribution of Hadoop. With open source software, it's always something we kind of have to think about. We're going to have to think about the components that are involved. There are a lot of third-party, not necessarily third-party, but other open source projects that are involved with managing a large Hadoop installation. So we'll talk a little bit about those and which ones you need and which ones are included and things like that. We'll talk about support. I know a lot of people think open source software is free, and it generally is in terms of using the software, but the support cost, and we'll talk about whether or not it's worth it for that. Then we'll talk about using the cloud versus an on-premises solution. There are pluses and minuses for both. Depending on your business needs, we can make a decision based on that. So open source distributions. I'm covering the main ones here, but I wanted to pull in a Dilbert because I saw this this morning. From now on, I want you to use open source software for everything we do. It's free. It's not free, especially if you're really wanting to get features. Actually, I wanted to show you guys something real quick, and let me do another quick demo. This one will be short. Okay, you guys can see my screen. Not to be advertising for Cloudera, most of the major vendors have tools like this now. All these components we have are a pain to manage and can be really difficult. This is Cloudera Manager, which is their just management feature. This is a fairly simple cluster I have running in my lab at my office. It's a 4-node VM cluster. I have a name node and three data nodes. And as you can see, this manages all the processes for me. I can't recommend using one of these products highly enough. Not necessarily Cloudera, but just any one of the any one of the management packs from the major vendors. Trying to do this on your own without
starting narrative.
Without support is a real challenge.
Presenter view slide pane. Presenter view can help you navigate. Escape. Desktop pane. Notification overflow.
Sorry guys, technical difficulty.
Tooltip. Zoom it. Tooltip. Help improve Microsoft. Context. Menu.
Somehow I turned on narrator. Okay.
Exiting narrator.
Sorry about that. Okay, we're back now. No more demos, man. Not having good karma today. Okay, my point about that little demo there was not to show you the Cloudera Manager, but just to understand that the management solutions are out there and they're pretty robust. That didn't take any work for me to build. It was very easy. Cloudera is a very good solution. I've done a lot of work with it. Hortonworks is the distribution you can install on Windows. I hesitate to recommend installing it on Windows just because so much support has been done around Linux. Intel has a distribution that's mainly used by them. MapR is kind of a rewrite of Apache Hadoop, and here's some more details on the next slide. So MapR is enhanced. They rewrote HDFS. They made it faster. It's very performant and enterprise ready, but it's also pretty expensive. And then lastly, Pivotal HD is an EMC product that has its own, uses Greenplum with business intelligence connectors that sits on top of Hadoop. It's also an interesting product. It's relatively expensive. You're paying a premium for EMC. So the main components of Hadoop are described below. The name node is the master of the system. It maintains the name system, which is the directories and the files within Hadoop, and it manages which blocks are present on each of the data nodes. The data nodes are the slaves in the system, and they're deployed on each machine, and they provide the actual storage. They're responsible for serving read and write requests for clients. The secondary name node is responsible for performing periodic checkpoints. And also in the event of a name node failure, you can restart the name node using the checkpoint. Early on in Hadoop, actually until quite recently, the name node was a single point of failure, but that has been improved. There's ways around it. So MapReduce is the framework for performing all this distributed data processing using MapReduce programming. In each job that you submit, or each query as the case may be, has a user-defined map phase, which is a parallel shared nothing process of input, and then it's followed by a reduce phase where it takes the output of the map phase and aggregates it. And typically, both those phases are going to take place within the Hadoop file system. And the main components of MapReduce are the job tracker, which is the master of the system, which manages the jobs and resources in the cluster, or the task trackers. The job tracker tries to schedule each map actual data being processed. So like the task tracker running on the same data node as the underlying block of data. And the task trackers are the slaves which are deployed to each machine. And they run the map and reduce tasks as instructed by the job tracker. Some of these other components on the side make our lives a lot easier in terms of managing a cluster. So Uzi is a workflow scheduler system to manage Hadoop jobs. Its design is to optimize the amount of jobs you can run. When we're talking about massive amounts of data, this is almost like getting time on an old mainframe where we used to have to share time with other users. Uzi manages that and schedules jobs optimally. Typically, it'll run on a given interval and check job resources and schedule. We showed Hive and we've talked about Pig, but Zookeeper is kind of an interesting tool. It's a centralized service for maintaining configuration information, naming, provided distributed synchronization services and group services in a distributed application. It's used for more things than Hadoop, but it's commonly used in Hadoop clusters. I don't want to call it clusterware because it's not, but it's almost like if you've used a Windows cluster before, it manages the communication. HBase and Mahout, we mentioned database and machine learning, and then Flume, just a log reader agent, and Swoop. So all of these things are things you have to think about installing in your cluster. If you use one of the pre-built installers, like from Hortonworks, you'll have the option of installing what you want to install, and so you don't have to install everything, but you can. Depending on what your needs are, is going to depend on what you want to install. But I definitely recommend Uzi and Zookeeper. They're kind of key, and having Hive is very nice. So you don't have to buy support. That's one of the great things about open source software. It gives you enough rope to hang yourself. It can be free. And as you can see, this house doesn't have that much support left to it either. I have a pretty simple tenet towards this. Are you Google, Yahoo, or Microsoft? If you are, then sure, don't buy support. If you're anybody else, you want to buy the support, even if you don't always use it a lot. It's nice to be able to call the vendor and say, hey, we're having a problem. Can you help us walk through it? In addition, buying support tends to get you, at least with Cloudera and Hortonworks, some kind of advanced features that you might not otherwise get. So it's a little bit like buying Enterprise Edition of SQL Server or Software Assurance from Microsoft. It's not nearly as expensive in terms of that cost. You're talking about $3,000 or $4,000 a server a year versus the cost of what SQL Server costs. It's definitely worth doing. So hardware. Hardware is kind of an interesting thing. If we're building an on-premises cluster, our data nodes are 12 to 24, 1 to 4 terabyte hard disk, and a JBOD config. So that means RAID 0. The typical hardware I see used in Hadoop clusters is the HP DL 380 or 385, so a 2U box, or I think the equivalent Dell is a 720, and there's a Cisco 200 series. But you typically want 2U boxes, just because in order to get the disk that you want to give you the hard drive, the storage density you need for your cluster, you're going to need to go with a 3.5-inch disk as opposed to 2.5-inch disk. And typically you can't fit those in a 1U server like a 360 or a 5, I forget the Dell. CPUs, quad, hex, octo, it's a little bit less important here. Running at least 2.5 gigahertz, so pretty much any current server is going to work. This isn't a great environment to use virtualization in. You can, and especially if you're doing a proof of concept thing, by all means. The cluster I was just demoing on is virtual. It runs fine for small tasks, but if you're starting to do large tasks that are shared, you're going to want to buy physical hardware. And I knew 64 to 512 of RAM is a pretty wide guideline. If you check the link on the bottom of the page from Cloudera, they'll give you a little more guidance. They really make those recommendations based on the nature of your workload. So for certain kinds of workload, you're gonna err towards the high end of the RAM. For other, you're gonna go towards the lower end. The most typical setup I've seen is about 96 to 128. That seems to be a sweet spot for a lot of customers. Bonded gigabit Ethernet or 10 gig E, and this once again is also going to depend on the storage density. Because remember, we have 3 copies of our data within our cluster, so that those data blocks are moving back and forth across the network as we load data into the cluster. A lot of that depends on the size of your cluster too. So if you're going to have a larger cluster, you probably want 10 gig Ethernet. Our name nodes, we can get away with a little bit less disk, 4 to 6 terabytes of disk. Same basic concept as our data nodes, except potentially less memory. You can generally get away with buying the same hardware. So the network bottleneck here. In larger clusters, like I say, intra-cluster movement of data can be a very large bottleneck, especially when you're doing data loads. If your cluster is more than a few nodes, it's probably worth it to spend the extra dollars for 10 gigabyte Ethernet. Excuse me, 10 gigabit Ethernet. It's not nearly as expensive as it used to be, so it's not nearly the impact to the cost of your cluster as it would be in the past. One thing to mention when I talk about clusters here, Having done a lot of work with SQL Server clusters and other database clusters in my past lives, this is a little different than that. It's a little bit easier. There's no clusterware to install. The software does all the clustering for you, so it's just talking to the other nodes over the network. So let's talk a little bit about cloud solutions. There are two main players that I'm going to talk about today. I think Rackspace may have an offering and somebody else may have an offering, but the main two things I'm going to talk about are on HDInsight on Windows Azure and Amazon Elastic MapReduce. They're both very viable solutions depending on your needs. The best use cases for these cloud solutions are where most of your data is coming from cloud applications and going into a cloud cluster. And I say that about this Hadoop on the cloud, and I'll also say that about SQL Server in the cloud. Those are the best scenarios where all your data is in the cloud. We'll kind of walk through the cost here in a slide. Of these two solutions, they're both viable solutions now. I'd still have to say Amazon's probably a little more flexible than HDInsight. It's been around a lot longer. Elastic MapReduce has been around for a couple of years, whereas HDInsight's only been live, I think, for about a year or so. HDInsight's running on Hortonworks distribution. Amazon's running on, I believe, their own proprietary. So let's look at the cost. And I gathered these this morning, so this is current. And I just kind of did a 7 nodes, so basically a name node and 6 data nodes cluster with 3 terabytes of data. The costs work out to be amazingly similar, which isn't a surprise because Microsoft and Amazon tend to go back and forth on pricing. We see here our costs per month roughly work out to be about just under $2,000 with Amazon and just over $2,000 with Microsoft. So it's roughly a wash in terms of cost. But if we pay attention to this last line here, they're both the same. We have this 12 cent a gigabyte data transfer cost. Both Microsoft and Amazon allow us to load data into their cluster, into the cloud for free. And this isn't just for the Hadoop service. This applies to anything. But if we're pulling data out of the cloud, so the quick example I can give is the Power Query I just ran. That data that I pulled down from Power Query would count towards my my monthly fare on 12 cents a gigabyte of data transfer cost. So what this means is if you have a large Hadoop cluster in the cloud, you want to do your processing in the cloud, and you potentially want to think about doing your BI in the cloud, because you're not going to want to be pulling that data down consistently for a couple of reasons. A, it's going to cost you a lot of money. 12 cents a gig is going to add up pretty quickly. And then B, it's not going to be as fast as if you're doing all of your operations in the cloud. So how do we decide when to use cloud versus on-premise? Premises says. That's hard to say, but it's grammatically correct. Cloud, I have a couple of things. Proof of concept project. So you want to get started with Hadoop. You want to just get started. You don't want to have to install anything. You don't have any VMs. Kind of like the way I've used SQL 2014 in Windows Azure. You just want to play. It's really great because you can turn it on, you can turn it off, and it's still there, and you're not paying for it all the time. Another really good example I've heard is for a short-term project. I heard about this last year on National Public Radio here in the U.S. A pharmaceutical company was doing some drug discovery research, and they needed 50,000 nodes to do this processing. I think it was protein sequencing. And they only needed it for, several hours. So they fired up 50,000 nodes at Amazon, ran their test, grabbed the results down, and then shut down the 50,000 nodes. Having worked in a large pharmaceutical company, I can tell you it would take years to acquire 50,000 servers, much less spin up Hadoop on them. So the fact that they were able to do that is pretty amazing, and that's a really great use case. I think there are a lot of really good use cases, particularly in that research space, where you have a short-term need to have a whole lot of computing power, and you can rent it, and that works out a lot better than buying it. The other scenario is you have data coming in from a cloud application. So typically the space where we see this is in mobile software. We're capturing a lot of data off mobile phones. iPhones, Android devices have a bunch of sensors in them. Each of the apps is free to capture a lot of that data. So those apps are going to be capturing and analyzing that data. So that's kind of the scenario where you'd want to use a cloud provider. On premises, you're looking at data that's mostly internal in nature. So if you're generating data from other systems that are internal, that's going to be when you're going to want to do it yourself. Data volume is very high, so that's where the cloud starts to lose its cost effectiveness because you're paying for the storage and the compute each separately. So if you're doing a lot on both of them, similarly to this computing demand is constant. So if you have people that are constantly using the data and you have a lot of data, you're going to need a lot of resources in the cloud. So it's likely to work out cheaper to provide to do it yourself. So what's the architecture for your company? And this is kind of a tricky question. A lot of it's going to depend on your company and your business needs and what your goals are with a big data project. One of the things as database administrators and data architects we're looking at is how to suit our skills to this, because it really is a different paradigm. There's not so much of a DBA role in the model as a system administrator and then kind of a data analyst / data hacker. So a person who's kind of querying the data a lot. So let's take a look at what a workflow can look like, and I'm worried we're going to lose this slide. So here we have data that we acquire, our source data, and we have structured data, semi-structured data, and unstructured data. So that unstructured data is where the NoSQL and Hadoop can come into play. We have machine-generated logs, web data, and text, image, audio, and video data that's coming in. That may go like here to our HDFS, and then we do MapReduce. We have our specialized hardware that's our big data cluster with a high-speed network. Eventually, we may have structured data that comes in from a data warehouse or OLTP data and gets eventually loaded to our enterprise data warehouse. And from here, we can combine these two sets of data and do really rich analytics, reporting and dashboards, recommendations that we wouldn't have been able to do before. It's gaining insight. So, you know, it is a new paradigm. Our old paradigms aren't going away. So using this kind of slide, you can kind of take I feel like this is a pretty good map of where you can go and how we combine our traditional data and then, you know, new sources of data. So the questions to ask, and this is really how you are going to determine your architecture and your strategy. You want to understand your corporate strategy towards big data. Big data, unfortunately, it's a buzzword. Like your CIO's probably read about it in airline magazines, and those are always the worst. So when your CIO asks about big data, you want to really understand what your strategy is and what your goals of doing the project are, right? You don't, you know, a very valid goal of using Hadoop is to save costs, to save storage costs from buying enterprise storage for databases, and to save database licensing costs. So we want to reduce our licensing volume on the data warehouse. That's a very valid goal. That's going to be a completely different project, though, than saying we want to capture real-time Twitter analytics and make decisions based on that. Those are two kind of different architectures. You need to understand if it's a short-term or a long-term project. Typically, if it's coming to an IT organization, it's going to be a longer-term project. The short-term projects, the way they're going to happen most frequently, I find, in larger organizations, is the department's going to become frustrated with the pace of the IT organization, and they're going to go rent capacity in Amazon or Microsoft. It's sad, but it's the way world works. I call it data center by Amex. So, but if it's a shorter-term project, that you weigh the cloud a lot more heavily. That's why I like to ask that question. Next, where is the data coming from? What are our data sources? You know, what kind of analytics are we looking to do on the data? So, are we coming from a traditional relational source where we're going to have very structured data, or are we coming from something that's completely unstructured and we're going to have to pull apart the data, like video data can be analyzed in Hadoop. It's challenging, and it's a lot harder to do than just analyzing the census data. And then my favorite, and this is my favorite question from back when I was DBA too, what is the anticipated data volume? And I always usually say take this and double it, and then maybe add 30% just to be safe. That's going to be how your initial cluster is sized, is based on data volume. And having good information in that space is pretty important. System resources. These are the first two are very similar. Cloudera and Hortonworks both have demo VMs that you can download and just attach to any VM solution. Unfortunately, they don't work great with Hyper-V, at least the Cloudera one. I'm not sure about the Hortonworks one. But they work well with VirtualBox, which is completely free. These are Linux VMs, and don't be scared off by Linux because it's got a GUI, that look and feel completely like, they have the complete Hadoop stack on them. So they have Hadoop, HBase, Hive, Pig, Impala, everything installed on them. And you can immediately start loading data. You can grab data off the internet. There are plenty of public data sets, or you can auto-generate weblog data. There's tutorials on them. And then similarly, you can download HDInsight for Windows. My one warning on HDInsight for Windows, I've had okay luck with it, but I've had it where it would hose a machine. So you may want to install it inside of a Windows VM just to cover yourself, because I've had some issues with the uninstall and install process. A couple of books I recommended, and all these links are hot, so I'll have Paco post the slides to the Big Data VC website. Hadoop Operations. This is a good guide on kind of what it's like to manage Hadoop, but it's also more of a DevOps book. The gentleman who wrote it, Eric Sammer, is one of the lead architects at Cloudera. I think he did a good job of writing a book for operations people, but at the same time explaining how the programming works to give you a fuller understanding of how Hadoop works. I learned a lot by reading that book. And then this last book, Hadoop in Practice, is kind of a demo book. It'll walk you through a bunch of demos that you can do to help you get a better understanding of how to play with it. So let's go to questions. Karen has a question on any tips on estimating data volume when there's variety and irregular velocity. That's a challenging one. No, not really. If you're doing that sort of, you just kind of have to build in. You have to build for max capacity at that point. If you're having very irregular velocity, that's another time where the cloud's a good use case, just because you don't need a whole lot of capacity at times, and other times you do. So typically I'd go with the cloud. Like and she replies, so estimate pad and increase unit of measure by 1. Yeah, basically. It's easier to build a larger cluster and remove capacity from it, like anything else, than it is to add capacity after you're going. It's not that hard to add capacity once you're going. One of the bigger challenges is if you go beyond a rack. I have another question here. In Hadoop 2.0, Yarn was introduced, and according to some of my reading, pushes Hadoop further from strictly a batch backend process system, backend process, to a system that can be used to serve up data for a transactional system. Thoughts on that? And that was Jim Hatcher. Jim, yeah, Hadoop 2.0 adds a lot of robustness to this. Yarn's going to be a big deal. It's taking a little while to catch on, but it's catching on quickly. So I think I agree. We're still a ways from transactional, in just that, not that the system can't be used for transactional purposes. I think for large organizations, the knowledge base isn't quite there yet. But with vendors like Cloudera and Hortonworks, they're going to make it a lot easier to use. Data security around Hadoop. It's getting a lot better. That was Surajit. There are still some gaps, but you can integrate with Active Directory or Kerberos. You can use the HDFS security. So security has gotten a lot better, I have to say. When I first started walking into this, it was kind of wide open. A lot of what Yahoo did was around security because their billing systems are running, and they had to make the Securities and Exchange Commission happy. Jason Horner, can you talk more about using Hadoop to replace your persistent staging layer in the data warehouse? Good idea or bad idea? I think it's an excellent idea. You can take in more data, and you can kind of do a lot of the designs that I've worked on in that space involve using MapReduce to do your initial ETL, and then using something like Scoop, I can't say Scoop, to take that data and load it into the data warehouse directly. I think that it's definitely a good approach. I mean, the goal of that's like to reduce the volume of data in your data warehouse, so you're licensing less database licenses. In my experience, anyway. I think that's all the questions I have. Thank you, everybody, and let me show my contact info real quick. Here's my email, jdantoni@anexinet.com. jdantoni.wordpress.com is my blog. I'll make sure these slides get to Paco, and I'll also have them on my site. And then lastly, my Twitter handle is @jdanton. Thank you, everyone.
Okay, thank you very much. It was a great session, and yes, I will upload your presentation and the recording. All right. So thank you very much. It was a great session.